everybody. Today we're going to be covering the properties of exponents. The first property is the zero exponent. So for any number, so anything raised to the zero power is going to be equal to 1. Okay, just something small that I want to point out. Anything to the zero power is 1, this is true. Okay, however, parentheses in all versions of exponents are very important. Okay, so let's say we had 4 to the 0 power, right? That would just, or I'm sorry, negative 4 to the 0 power. Okay, 4 to the 0 power is 1, but you still have that negative out in front that you need to account for. Okay, now if there were parentheses around the negative 4 to the 0 power, okay, anything to the 0 power is just 1, and you do not now need to account for that negative. Okay, so the difference is in this version, we had no parentheses, so we evaluated for the 0 and then put the negative out in front. In this version here, there were parentheses, so we evaluated negative 4 to the 0 power, and then we were done. That is definitely something important to know and to understand when it comes to simplifying expressions with exponents. Negative exponents, okay? The technical definition is a to the negative n is the reciprocal of a to the n. That's your technical definition. However, I like to put it in simpler terms as either bring it to the bottom or bring it to the top. So 4 to the negative 2, that's over the imaginary 1. So you need to bring that 4 to the negative 2 down. When you bring it down, the negative, this negative right here, that goes away now. Notice there's no negative now, okay? And it becomes 1 over 4 squared, which I know 4 squared is 16, okay? So any number a to the negative n, okay, it becomes 1 over a to the n. So what I mean by bringing it to the bottom or bringing it to the top, let's say you had 1 over x to the negative 3, right? The reciprocal of that, okay, would mean bringing the x to the negative 3 to the top. So it would become 1 over, x to the third over 1, okay? Now, if it was written x to the third, negative third over, say, 2, okay, you would bring it then to the bottom, and then it would become 1 over 2x to the third, okay, and you'd be multiplying x to the third by that 2 that's already in the bottom. So that's why I don't really like the word reciprocal, because it can be misleading. If you were talking about the reciprocal of x to the negative third over 2, you would think you would just flip it, which is not the case. I like to use the words bringing it to the bottom or bringing it to the top, depending on where that negative exponent is. We're going to get further into that as well as we go on. Okay, the next is the product of powers property. Okay, if you're multiplying two exponents, all right, you can then you can add the exponents if they have the same base. Now the base is this number in green here. So in this case, they both have a base of 4. Therefore, you can now add these exponents here, okay, and end up with 4 to the 9th power, which is a lot simpler than 4 to the 6th times 4 to the 3rd. Okay, so whenever you're multiplying two exponents, you can add them to simplify. And the opposite applies to the quotient powers property. If you are dividing two exponents, right, you may subtract those exponents. It's got to be the top minus the bottom, the numerator's exponent minus the denominator's exponent, okay? When you do that, 4 to the 6 minus 3, it simplifies it to 4 to the third, which is a lot easier to deal with. And that's generally the what we're looking to do when we are simplifying these exponents, is we're just trying to make it easier on ourselves. The power of the power property. Okay, so here we have 4 to the 6th to the 6th to the third power. Okay, the 6th to the third power, when you have a power to another power, you can multiply those two powers to simplify it to, say, for in this instance, it would be 4 to the 18th power, 4 to the 6th times 3. Okay, so it's a power of a product, or a power of a power property. Last, we have the power of the product property. In this case, it's almost like you're distributing that exponent, and you're going to end up with 3 to the 5th times 2 to the 5th, okay? This is super useful when you're simplifying something like 3x squared to the third power, say, okay? You can now change that exponent to 3 to the third and x to the 2 times 3, right? 3 to the third power is going to be 27. X to the 2 times 3 is x to the fifth. And that's a lot simpler than dealing with something that looks as ugly as this one does. Okay, so this is super useful, and the power of a quotient property is essentially the same thing, where you're distributing that fifth power to the 3 and the 2, okay? Again, useful if we're doing something like x squared over 3, and then that's being put to the third power. You can distribute that 3, so it could be x to the 2 times 3 over 3 to the third, right? Okay, x to the 2 times 3 would be x to the 6th over 3 to the third would be 27. And again, it's just easier to look at. It's a lot nicer. All right, moving on. So we're actually to the point in the lesson where we're doing extra practice. What I personally would encourage you to do is, at this point, pause the video, complete a problem, watch that problem. Pause the video, complete a problem, watch that problem. Okay? This way, you get your practice on your own. You prove to yourself that you can do this. Okay? And then on top of it, you're able to immediately check your answer with an explanation. Okay? I wouldn't advise you to go through and complete all the problems and then check your answers, because if you have a misconception, you could get every single problem wrong because of that misconception. Whereas if you do a problem, watch a problem, okay, you're able to dispel any misconceptions you might have right off the bat, and then they won't carry over into the next problem. It'll be a lot less discouraging, I feel like. So 3 to the 0 power. Well, anything to the 0 power is going to be 1, okay? Negative 2 to the 0 power, okay? Negative 2 is in parentheses, so negative 2 to the 0 power is going to be 1, all right? 3 to the negative 4, okay? I like to think of this as a two-stepper, okay? Step number 1 would be to, like I said, bring this into the bottom. So it now becomes 1 over 3 to the 4th power. Again, I want you to notice that the negative does not exist here anymore. Once you use the reciprocal, or bring it to the bottom, as I like to say, that negative will go away. So 1 over 3 to the fourth, okay, I know 3 to the fourth power is 81. And that should be my final answer in this case. Okay. Number 4. Oops. Negative 4 to the negative third power. Again, another two-stepper. The first thing I want to do is I want to bring that down into the bottom. So it's going to become 1 over negative 4 to that third power. Okay. Now, negative 4 to the third power, keep in mind, okay, it's negative 4 times negative 4 times negative 4. Okay. It's going to be equal to negative 64 because of that third and last negative number. So this becomes 1 over negative 64. Okay, that negative in our answer, okay, has absolutely nothing to do with the negative exponent. All the negative exponent did was bring this down into the bottom. Okay. Moving on, number 5. Again, we're moving into the multi-step problems. All right. So the first thing I would do with number 5 is I would get rid of the 5 to the 0 power on the bottom. So leave 2 to the negative third alone on top, 5 to the 0 power. I know that's 1. Okay. Now, I have to get rid of the negative exponents. Okay. So you should never, ever, ever leave a negative exponent in your answer. So this negative exponent needs to be brought down to the bottom. So it becomes 1 over 2 to that third power. Okay, 2 to the third power I know is 8. So 1 over 8 should be your final answer. Number 6. Again, a multi-stepper. Okay, both of these exponents are negative. So right away, I'm just going to move them around to the proper place to get rid of the negative exponent. So negative 3 to the negative second power has to be moved to the bottom. 2 to the negative third power has to be moved to the top. So we end up with 2 to the positive third power over negative 3 to the positive second power. 2 to the third power, I know that's 8. Okay, 3 squared I know is 9. And with that negative out in front here, I have to put that out in front here. Okay, if it was negative 3 in parentheses squared, then it would be positive 9. But the negative is not in parentheses, therefore it just stays out in front. Okay, so your answer should be negative 8 over 9. Number 7. Okay, again, I'm getting rid of that anything to the 0 power because it's just easier. So 4 to the negative 1, I want to keep. Negative 7 to the 0 power. So 7 to the 0 power I know is 1, but don't forget about this negative out in front. Okay, so we have to put that negative out in front. Now we need to take care of the 4 to the negative 1 by bringing it down. Can't have a negative exponent in our final answer. So it becomes negative 1 over 4 to the first power is just 4. So we can leave our answer in simplest form this way. Number 8. Okay. Again, I'm going to take care of that 0 property. Why should we be dealing with any extra numbers that we don't need to? So 3 to the negative 1 I'll leave over negative 5 to the 0 power is 1. That 3 to the negative 1 I'm going to bring into the bottom. So it's going to become 1 over 3. And that should be your final answer for number 8. Okay. Okay. Now that we're moving on to the next section, we were dealing with numbers. Okay, so we were getting numbers as our answer. When you move on and you include variables in your expression, Okay, you're not going to have a number as an answer anymore. You will have just a different, simpler expression. So, that being said, z to the 0 power, we know that anything to the 0 power has to be 1, right? So I don't care if z was the square root of 2 to the 0 power, it's going to be 1, okay? Number 10, a to the negative 8th, okay? You don't want that negative exponent. I know this problem seems very simple, but you cannot have a negative exponent in your um, in your expression, so you want to bring that down and make it 1 over a to the 8th power as your final answer, okay? 11, again, multi-step problem, okay? I'm going to leave the 6 out in front. A to the 0, we know is 1, okay? And b to the negative 2nd power, okay? Remember, you have to bring that down, okay? All these are being multiplied, right? So I left the 6, a to the 0 I changed to a 1, b to the negative 2nd now is going to become 1 over b squared, okay? So 6 times 1 I know is 6 times 1 over b squared, right? And then we can multiply 6 times 1 is 6. 1 times b squared is b squared. Okay, and that is going to create our simplified expression that's a lot easier to look at than the original. A lot less unnecessary information. Okay, 12. Again, multi-step. You're going to be seeing this more often now. I'm going to leave that 14 as is. M to the negative 4th, I'm going to change it. I'm going to change it to 1 over m to the 4th. I want to get rid of that negative exponent. N to the 0 power, anything to the 0 power I know is 1. So I'm going to simplify the 14 times the 1, and I'm going to make it just 14 times 1 over m to the 4th. As we did earlier, you put 14 over that imaginary 1, multiplying across the top, 14 times 1 is 14. Across the bottom, 1 times m to the 4th is m to the 4th. And our final answer should be 14 over m to the 4th. Okay? If you take these problems step by step, they really do become much easier to handle. They can be overwhelming looking at something like number 13. However, if you take it one step at a time, it becomes okay. All right? So, like I said, I'm going to get rid of any unnecessary information. So, 3 to the negative 2 I keep, r to the negative 3rd I keep, but s to the 0 is 1, okay? Now I know I can't leave negative exponents in my expression, so 3 to the negative 2nd I'm going to bring down. R to the negative 3rd I'm also going to bring down, okay? So it becomes 1 over 3 squared r to the 3rd, and 3 squared I know is 9 r to the 3rd. Okay? I hope at this point you're starting to see patterns and that this is becoming easier for you. So, 2 to the 3rd I know is 8 times a to the negative 3rd I'm going to leave. Okay, 8 to the negative 1 I'm also going to leave. B to the negative 5th I'm going to leave. And c to the 0 is just 1. Okay, now this 8 to the negative 1 needs to be brought to the top. Okay, so I'm going to do that first. So it's going to become 8 times 8 to the negative 1 when I get brought to the top is just 8 times a to the negative third over b to the negative fifth times 1 is just b to the negative fifth. Okay? Now, 8 times 8 I know is 64, a to the negative third over b to the negative fifth. I'm not done yet because I have to get all of the negative exponents out of my expression. So a to the negative fourth needs to be brought down, while b to the negative fifth needs to be brought up. So we do just that. 64 times b to the positive fifth, I brought that up, and a to the third is now in the bottom. And that is our final answer. We have no negative exponents, therefore we know that we are done. Okay? Moving on to number 15. Okay? This here represents that quotient property that we were talking about earlier. So 3 to the fifth over 3 to the third. 3 to the fifth is a very large number. A number that I don't want to deal with. So this is when that quotient property comes into play. You can change 3 to the fifth over 3 to the third to 3 to the 5 minus 3. Okay? So 3 to the 5 minus 3, 5 minus 3 is 2. Okay? And 3 squared, well, I know 3 squared is 9. Nice and easy. Okay? Now, could we have done it the other way and found 3 to the fifth to be, all right, well, I don't know what it is. I have to figure it out. 2, 3, 4, 5. So 3 to the fifth is 243 over 3 to the third is 27. So 243 divided by 27 comes out to 9. So this here, okay, this proves that yes, this property is valid and it does work, okay? But I would much rather do something like this because it is so much easier and you can make the computations in your head. Okay, that's what all of these properties are about, making life easier on you guys. All right. So number 16, again, negative 2 to the 7th power. That's something I don't want to do. So negative 2 to the 7 minus 5, that's something I can do. 7 minus 5 is 2, and negative 2 squared, since the negative is in the parentheses, this means it's negative 2 times negative 2, which is a positive 4 as your answer. Okay? All right? Okay, so negative 5 to the third power times negative 5 to the third power. We have the same base, so we can use that product property, and we can use negative 5 to the 3 plus 3 power. So that's negative 5 to the 6th power. Okay, and negative 5 to the 6th power is going to give us an answer of 15,625. Okay. All right. So, number 18, power to a power property. Whenever you have a power to another power, you can simplify it by multiplying those powers. So q to the 5 times 3, this is going to simplify the q to the 15th. Again, easier to look at, easier to handle, easier to comprehend than the original expression. Okay, a to the negative 4th squared, that's going to become a to the negative 8th. Negative 4 times 2 is negative 8. Okay, we've simplified it, but we are not done because we have that negative in the exponent. So we need to bring our expression down into the denominator. Now we're done. You cannot leave a negative exponent in your answer. Okay, 20. Okay, we have another two-stepper. So c to the fourth times c to the fifth, that's going to become c to the 4 plus 3 over c to the sixth. C to the 4 plus 3 becomes c to the 7th over c to the 6th. And c to the 7th over c to the 6th, we can change that to 7 minus 6, which leaves us with a final answer of c to the 1st, which in turn is just c. Okay? Again, take it step by step, okay? 21. Okay, we're going to distribute that fourth power to the negative 4 into d. So we end up with negative 4 to the fourth power times d to the fourth power. Negative 4 to the fourth power is 256. D to the fourth power is just going to say d to the fourth power, and that's our final expression. 22. Okay, the first thing I'm going to do here is get rid of this negative exponent. So I'm going to bring this whole thing into the denominator. So negative 3f to the positive third power now, because it's in the denominator like it should be. Okay, the next thing I'm going to do is distribute that exponent of 3 to negative 3 and f. So it's now going to become 1 over negative 3 cubed f cubed. Negative 3 cubed, okay, so negative 3 times negative 3 times negative 3, well, that's going to be 9 times negative 3, which is going to be negative 27. So this becomes negative 27 here, and f to the third power, well, that's just going to stay f to the third power. All right, that is our final expression. 23. Okay, first thing I'm going to do again is get rid of that negative exponent. So I'm going to use the reciprocal of x over 4, and now it's going to be to the positive third power. Then I need to distribute that third power throughout the expression, so it becomes x to the third over 4 to the third. Okay, x to the third I can't simplify, but 4 to the third I know is 64. Okay, so our final answer is x to the third over 64. Okay, our last problem here I'm seeing is a, what do you call it? Word problem. Sorry. Okay, about a rectangular prism with a length, width, and height. So when in doubt, draw it out. Okay, I'm drawing my rectangular prism. Not too shabby. Normally I'm very bad at drawing. Okay, my rectangular prism has a length of x, a width of x over 2, and a height of x over 3. And they're asking us to find an expression that represents the volume of the prism. Well, I know that volume is the length times the width times the height. So when I multiply these three numbers, that first x is over an imaginary 1. So the x's across the top, x times x times x, is actually x to the third. And 1 times 2 times 3 is 6. Okay, so essentially, one of these 4 possible answers should end up looking like x to the third over 6. Actually, there's multiple that could apply. So there's a couple of these answers, and they should look like x to the third over 6. So we're going to get to simplifying these and seeing which ones work. So part A, we have 6 to the negative 1. Well, I know that that changes to 1 over 6, and that's multiplied by that x to the third, which is over an imaginary 1. When we do this, 1 times x to the third is x to the third over 6 times 1 is 6, and that is exactly the answer that we're looking for. So part A is definitely a possible answer. Okay, part B, 6 to the negative 1, that changes to 1 over 6, times x to the negative third changes to 1 over x cubed. So that becomes 1 over 6x cubed, and that is not looking like what we wanted. So we move on. All right, part C, we need to distribute that negative 1. So we end up with 6 to the negative 1 times x. Negative 3 times negative 1 is positive 3. The 6 to the negative 1 gets brought down, so it's 1 over 6 times x to the third over 1, which becomes x to the third over 6. That's exactly what we wanted. So part C is definitely an answer. All right. Now we just need to test part D. 2 to the negative 1 becomes 1 over 2 times 3 to the negative 1 becomes 1 over 3 times x to the third becomes x cubed over 1, right? 1 times x cubed is x cubed. 2 times 3 times 1 is 6. That's exactly the answer that we were looking for. So your answers to number 24 should be A, C, and D. Okay, you've now completed section 6.1, and you can move on to section 6.2.